Welcome to another of our Mirteq video instruction series. In this video I'll explain how simple and fast it is to make molds with MIR-300. MIR-300 is our microfiber reinforced mold making material. It comes in two versions. The MIR-300 itself, which is a softer microfiber reinforced material that can be readily machined and sanded because it incorporates hollow plastic microspheres. On the other hand, our MIR-302 is a far tougher microfiber reinforced material that contains ceramic microspheres. These microspheres may cause excessive tool wear if you plan on machining it. It is also more difficult to sand. There are two primary reasons for using the MIR tooling systems for making a mold. Firstly, the MIR-300 series material allows you to quickly, easily and inexpensively produce high quality molding tools. Secondly, the MIR-300 series products produce a superior mold surface with no fiber print through, even after the mold goes into heavy production. This is because the resin systems are low shrink and incorporate only microfibers and microspheres that are far too small to see. The result is a surface with absolutely no distortion. You can contrast this to traditional mold making techniques where resin shrinkage allows the surface glass pattern to transfer to the mold surface. Often this occurs after the mold is seasoned and in production, causing costly additional mold rework and recasts. There are two ways to make molds with MIR-300 resins. The first is by spraying or brushing the MIR-300 material up to 1/2 to 3/4 of an inch thick onto an undercut sealed polystyrene foam. You then let the material cure for 24 hours before CNC machining it. This method has the advantage because it eliminates the need to make a plug. The material is also strong enough and dimensionally stable, so that for most small and even some medium-sized molds, it does not need additional reinforcing. If you want to find out more about the CNC machined mold making method, give us a call directly. The second and more common way to make molds with the MIR-300 resin is to back up the MIR-300 against a pre-prepared gel-coated mold surface. In this video we are going to demonstrate how the material can be used in this manner, which is how we make most of the prototype molds in our shop. To kick off this demonstration, I'm going to assume that we already have a master pattern or prototype. So the first step in this process is to seal the plug or CNC machined master and work out where the parting lines should be. After that, we make up the parting board. We then set the part on the parting board and seal the entire edge of the part to the parting board with a clay or putty filler. Once the part is in position, we wax the master pattern and parting board as per the wax manufacturer's instructions. We then apply a PVA to the master board, again following the manufacturer's instructions, which usually require about 2 coats. The next step is to spray on a high temperature tooling gel coat, again as per the instructions. Now we are ready to apply the MIR molding resin. In this case the MIR-300, which is a chocolate brown in colour. We can do that either with a spray gun or a paintbrush. The bigger the brush the better. We normally use a 2-inch or 4-inch brush depending on the size of the mold. For larger parts, spraying the MIR-300 with a 1/8 inch nozzle can be more efficient. We need to apply 3 coats of the MIR-300, 1/8 of an inch at a time. We let the first layer exotherm and cool down to room temperature, which takes about 3 hours, before applying layers 2 and 3. By stabilizing the first layer, we minimize any shrinkage. MIR-300 does not shrink much, about 1/2 of 1%, which is not really noticeable on small molds or where the material is held in place by the master part. It is, however, something that mold makers need to be made aware of. With larger molds, our clients have been known to lay down a sheet of traditional fiberglass laminate and let it cure in place before applying layers 2 and 3. That too is obviously quite effective. The final step is to back up the MIR tooling resin with 2 chopper gun layers, each about 1/8 of an inch thick. This reinforcement method is fast and quite easy to achieve. Alternatively, a glass layer can be done with a rolled out traditional fiberglass laminate. This fiberglass layer gives the mold additional strength and rigidity and is an essential insurance policy. Now when you want to make the B mold, all you do is repeat the steps we've just gone through. For larger molds, we also suggest that they are reinforced with either a metal frame or metal tubing, and in addition we use a 1/2 inch plywood rib to ensure that the mould will not warp and inflate. Even when we inject at 1 pound per minute, the pressures in these moulds are quite considerable, and this is exacerbated by the heat, so these reinforcing precautions are quite important. Having a really rigid mould makes it so much easier to seal. In this case we're just clamping the mould. However, we could easily have made a vacuum seal. It just depends how hard the mould needs to work. If you want to incorporate a vacuum seal, please refer to our mould making user manual. One last point. To improve the finish and reduce your trimming, we suggest that all edges are moulded round. We therefore suggest your parting lines are moved off to the side rather than onto the centre of any curved edges, as per the diagram. We have made a number of MIR-300 and 302 moulds. They've proven to be reliable, durable, stable and structurally sound. They're also easy to manufacture, involve minimal labour and are really quick to produce. So looking at the time taken to produce the mould you are seeing in this video, sealing the master and making the parting board, well, that's the same no matter what process you do. Waxing the pattern, we allowed 15 minutes for each of the A and B side moulds. The PVA layer, 5 minutes, gel coat layer, 5 minutes, 3 layers of MIR, 60 minutes on each side. Fiberglassing, 10 minutes on each side. That's a total of 95 minutes on each side, so you can see there's not a lot of labour involved in this process. At this point, the only remaining step is to finish the mould surface for production. If you have an existing mould prep and maintenance program, we suggest you follow that to complete the mould. If not, here is a program that we use in our own moulds at Mirteq. The first step is to wet sand the mould. You can start at 320 to 400 grit and work your way up to as high as 1200 grit for an A-class finish. The next step is to buff and polish the mould. For this step we use 3M Super Duty buffing compound followed by 3M Imperial compound and finishing material. At this point you apply a PVA film to the mould and run your first part. The PVA film creates a physical barrier between the mould and the part, ensuring that our first pulls are successful. The exotherm generated by the first 3 or 4 parts helps post-cure or season the mould. This post-curing removes any free styrene from the mould surface, which would otherwise cause parts to stick up. Remember, the PVA treatment must be reapplied for each of your first 3 or 4 parts. After moulding the first few parts with the PVA treatment, we complete our mould prep using the Chemtrend system. We first apply the Chemlease Mould Cleaner EZ. This is followed by 2 coats of the Chemlease 15 sealer. The sealer will fill in any microporosity in the mould, which is the other major cause of parts sticking up. Finally, we apply 6 coats of the Chemlease RMB EZ release. So there you have it, a finished mould ready for production. And finally, one last sales plug from me. If you ever need to repair or rebuild your mould surface, ask us about our mould repair material MIR-360. The MIR-360 utilizes our microfiber reinforcement technology, and our clients like it because it is tough and permanent, so they keep their moulds in production instead of in the repair shop. I hope this video has been beneficial. If you have any questions or would like to follow up with us, please don't hesitate to give us a call.